When looking for exoplanets, we tend to search for planets as similar to Earth as possible. But it's possible that some planets out there may be able to support life and the evolution of life much better than Earth can. It makes sense. Over millions of years, humans, or even just life in general, have successfully evolved on this planet. One species in particular have gained intelligence and became technologically advanced, so taking the characteristics of this planet and looking for exoplanets with the same characteristics is not a bad idea. However, we haven't found any exoplanets that we're confident in having life. After all, one of the most common camps for the Fermi paradox is the simple notion that Earth is exceptionally rare. So rare that there may only be one such planet per galaxy or less. This is called the rare Earth hypothesis and raises the idea that we are alone, at least in our galaxy, possibly even in the universe. I myself find it a compelling argument in the Fermi paradox and find it very interesting to discuss. The combination of the particular star that Earth orbits, the distance that Earth orbits at, the composition of Earth and so on makes this planet habitable. But could there be exoplanets that are more habitable than Earth? That may seem like a stupid question at first, because as we all know, Earth is habitable and gets the job done, so how could there be planets any more habitable? Well, for one thing, a star with a longer lifetime than our current one would give a civilization more time to evolve. Everything on Earth completely relies on the Sun, as without it we would not be here. With that being said, eventually the Sun will render Earth uninhabitable as it comes to the end of its main sequence phase in about 5 billion years, but will most likely wipe Earth clean of life long before its red giant stage. So stars with a longer main sequence phase would be more favoured for planets orbiting it. K-type orange dwarfs have exceptionally long lives, lasting between 15 and 30 billion years, much longer than the current age of the universe. This type of star has a smaller mass, resulting in a longer life, and emits less harmful radiation than G-type main sequence stars like the Sun. Other stars such as M-type stars, while they have very long lifetimes, are more likely to have tidally locked planets in orbit around them. Tidally locked planets would never be super-habitable, as one side is extremely hot, always facing its host star, and the other side is extremely cold. So at the very least, the only habitable zone on the planet where life could develop would be a narrow band between the hot and cold side. This would most definitely not classify as super-habitable, because there's very little land for life to develop, putting them at a disadvantage which would not benefit life. Another factor that comes into play is the habitable zone of a solar system. Every star has one. For cooler stars it will be closer to the star, for hotter stars it will be further out, and for stars like the Sun it is about in the middle where Earth orbits. Both Venus and Mars are also considered to be in the habitable zone of our solar system. But just because a planet is in the habitable zone does not mean that that planet is guaranteed to have life. From what we've noticed here on Earth, not only do you need to be in the habitable zone in order for liquid water to be available, but a magnetic field is also necessary, as well as a stable atmosphere, a suitable air composition for life, and so on. Previously, I mentioned that a star with a long lifetime is preferable. Well, even if a planet had all these factors, so a magnetic field, a thick atmosphere and so on, it may still not last for a long time, despite the star's exceptionally long lifetime. This is because it's also necessary to have a stable habitable zone. Firstly, a stable habitable zone implies that the habitable zone should not move greatly over time. As a star ages, it increases in luminosity. Therefore, the habitable zone will move further out while the planet's does not. If this happens too quickly, the planet will have a limited period in which life has a chance to emerge and evolve. Secondly, in a stable habitable zone, a celestial body with a large mass should not exist in or near the habitable zone. This would prevent the formation of rocky planets. A fantastic example of this is the asteroid belt. The asteroid belt would have most certainly coalesced into one big rocky body if Jupiter were not there. I don't think it's a coincidence that the first 4 planets in our solar system are rock-based and the remaining ones are gas giants. It's thought that this isn't a coincidence, as it's seen in many other star systems. Anyways, a super-habitable exoplanet should have a stable habitable zone in order to allow life on the planet to have as much time as possible. Another feature favourable to life is plate tectonics. Plate tectonics are crucial to life for a few reasons, such as the recycling of carbon, or the carbon cycle, which helps maintain global temperatures. Plate tectonics also play a large role in Earth's strong magnetic field, which in turn deflects solar wind, which would strip away our atmosphere. There are many other factors that would make a planet better suited for life, such as air composition, the best temperature and pressure, and ocean depth may also help in supporting life. It turns out to make Earth as habitable as possible, it would have to be about twice the mass of Earth, and then it would have to be a quarter larger of the current radius of Earth. This larger planet would obviously give future civilizations a lot more space than we currently have on Earth, and would allow for flat terrains and shallow oceans, as well as a strong magnetosphere which would deflect more solar radiation. 2 Earth masses is the optimal mass for active tectonic plates. It would orbit a K-type orange dwarf in order to have as long a life as possible, which comes with a stable habitable zone, giving life on the planet a lot more time to develop and evolve. As Earth is thought to be located in the inner edge of the habitable zone, a planet would be best suited to be in the centre of the habitable zone, as life would fare better there. In the solar system, life on the planet would also benefit from there being less rocky bodies orbiting the host star, such as asteroids and comets, as it's possible that one could collide with Earth and cause a mass extinction, further preventing and delaying the evolution of life. With all these factors considered, it gives us the optimal planet for life. So when searching for exoplanets, we have a better idea of just how habitable a planet really is. Comment down below your thoughts on super-habitable exoplanets. Make sure you subscribe for more content on astronomy and futurism. If you enjoyed this video, check out my most recent video, a previous video, or this playlist. Thank you so much for watching. Have a nice day.